Hi everyone, and welcome to MathSux. This video is going to help you pass the Algebra Common Core Regents. So in this video we're going to do this one question at a time. Here is question 35. So there's multiple parts to this question, so let's look at this. The following table represents a sample of sale prices in thousands of dollars and number of new homes available at that price in 2017. So let's just take a quick look at this chart. We have sale price in thousands of dollars and then number of new homes available. Okay, so this is like our x and this is our y. And now for the first part of our question, state the linear regression function that estimates the number of new homes available at a specific sale price p. So linear regression function, so we're going to need to use our calculators. Yeah, so these questions are super weird because they don't show you how to do this by hand, but they show you how to do it on a calculator. So I'm just going to use my calculator. I use a TI-83 Plus. So the first thing you're going to want to do is go to Stat, Edit, and then enter in the table. So I already entered this in. We have 160, 180, 200, 220, 240, 260, 280. Just double checking myself because it's so easy to make mistakes, which I always recommend double checking yourself. 126, 103, 82, 75, 82, 40, 20. So we look good. So now we can move on to the next step. So to get the linear regression function, we're just going to go Stat, Calc, and then down to linear regression. Enter. And this gives us what we were looking for. So linear regression function, so we get y equals ax plus b, which is kind of like y equals mx plus b, right? So that's kind of what we're making here. And then they give us the values for each. So they give us a equals negative 0.792857. And it goes on. And b is equal to 249.8571429. And so if we look at this, we just want to plug these into, so for a we want to plug this in, and for b we want to plug this b in, and we went around to the nearest hundredth like it asks us to. So let's just do that. We got y equals a is negative 0.7 tenth hundredth place, right? 10th hundredth place. And then plus x plus 249.86 for b. So just rounding that up. And that's our answer for the first part of this question. So now for the second part of our question, state the correlation coefficient of the data to the nearest hundredth. Explain what this means in the context of the problem. So the correlation coefficient, again, we're going to use our calculators to find that. So now for the second part of our question, to find the correlation coefficient, we always want to make sure the diagnostics are on the calculator. So we're going to go to second, 0, again, then go all the way down to diagnostic on. Enter, enter. So, and then we're just going to find the correlation coefficient the exact same way we found the linear regression equation. So we go to Stat, Calc, go down to linear regression, enter, and then see we get the correlation coefficient, which is represented by this letter R here. So let's just write down what it is. We get R is equal to negative 0.9542585,415. And we want to round it to the nearest hundredth place. So R equals negative 0.95. And explain what this means in the context of the problem. So correlation coefficient, so the more correlation coefficients, the closer the number is to 1, the more correlated the two items are, the two variables are. So since this is close to 1 or negative 1, so since this is close to negative 1, the negative 0.95, it's 0.05 away from being negative 1. We know that they're very closely related to each other, but they're actually inversely related to each other because of this negative. So we're going to write that sale prices and number of new homes available are inversely related to each other. So what that means is that whenever sale prices are up, then the number of new homes is down, and vice versa. So if sale prices are down, then the new homes number of new homes are up. So when one is decreasing, the other is increasing. Another way, so just a little way to visualize what correlation coefficient looks like. So a strong positive relationship of 1 is like y, like a slope, y equals x. So it's like a slope of 1. So this is positive. This is negative. This is what we have here. This is an inverse. This highly negative correlated or inverse. And then there's correlation coefficients where they're not related at all. They look something like that. So that's just a little background on correlation coefficients, and that is the answer to our problem. Need more practice? Check out MathSux.org for more questions. Link below. Also, don't forget to subscribe. Happy calculating!